Lesson 32, New Institutions of Expanding Knowledge and More. So new institutions of expanding natural knowledge. New knowledge, this new knowledge of the scientific revolution, just like the Renaissance movement that we talked about before, is in opposition to scholasticism. Scholasticism relied a great deal on the authority of the ancients, which so did the Renaissance. The Renaissance disagreed with which ancients to agree with, and now the scientific revolution is going to go a little bit further and say, hey, the ancients didn't know everything, and we need to be very skeptical about points they make without any evidence given. So universities that were entrenched in scholasticism were somewhat reactionary, but opponents of the time exaggerated the resistance to these new ideas. Descartes, Hobbes, and Locke all criticized universities. We've talked about them. Descartes in his deductive method. Hobbes wrote the Leviathan and argued that absolute monarchs should be able to rule even when they're tyrannical, because the other option is anarchy, which is even worse. Locke argued that under the social contract, if a monarch was tyrannical and did not protect your natural rights, that meant they broke the contract and you could overthrow them and set up a new contract with a new government. They all criticized universities. Medical schools were fairly open to new learning, even more so than regular universities, who were somewhat resistant. Universities were still important for funding research, but they were considered too slow to change. And they were too slow to change because if they hadn't been, there wouldn't be any need for anything new, any new institutions of learning. So this slowness to change on the part of universities led to societies and academies, such as in 1657, the Florence Academy of Experimentation; in 1660, the London Royal Society; 1666, the French Academy of Science; and 1700, the Berlin Academy of Science. And here we see an idealized sketch of what these academies were doing and how busy they were. This is a bit, I have to imagine there wasn't so much going on at one time. It gives you a sense. Notice the time frame, 1657 to 1666, three very important societies or academies open up. This kind of gives you a real good, strong sense of when this stuff is really pushing hard. So these societies, what do? They heard papers, they observed experiments. You gain credibility as a thinker and a scientist, or at the time a natural philosopher, if you had connections to these societies. The natural philosophers involved saw their science, their natural philosophy, as fostering civility, and they argued that you could, in this particular area, you could set aside religious and political conflict and concentrate on some fundamental truths that nobody really could argue about. It was a crossroads for elites, artisans, explorers, and even workers. These were institutions where wealthy people patronized, in other words, they funded, sponsored a lot of what was going on. Artisans were the craftsmen who built a lot of the devices used by the natural philosophers. Explorers went out there and found stuff for these natural philosophers, these scientists, to examine. And of course the workers, they're going to interact with everybody, because you need workers wherever you're at. Science promoted effective government and promoted economic growth. So scientists are going to improve production. They're going to improve navigation and artillery. So they have military applications, which governments, of course, are going to be interested in. And some of these guys in Britain, they were called projectors. These kind of entrepreneurial scientists who would go out and try to improve the world and through science. And there was an increasing appreciation for toleration and liberty during this period of time amongst these natural philosophers, which is going to lead to the Enlightenment, which we'll study later. Here you see a picture of an old telescope and Leibniz's reckoner, a really cool device which could add, subtract, multiply, and divide. It was the first one, basically the first calculator to be able to do all those functions. Women in the world of scientific revolution Women were mostly excluded from universities until around 1900. Here we see a picture of Queen Christina and Descartes with some other folks. So, noble women. They might encounter scientists patronized by their family, sponsored by their family, but they usually had no real choice in patronage. They really weren't the ones who usually controlled the spending on promoting natural philosophy, and they usually didn't contribute their own ideas. An exception is Queen Christina of Sweden, who sponsored her own scientific work, and there you see a little cutaway of that painting showing her talking to René Descartes. Another exception, Margaret Cavendish, the Duchess of Newcastle. She contributed her own work, and she was the only woman who was invited to the Royal Society of London in the 17th century, which points out just how exceptional she must have been, and also what an exception it was for a woman to be allowed into the Royal Society of London, demonstrating the discrimination of the time period. One woman in a century gets to go to the Royal Society of London. Women in the artisan class had more access to the new science. Maria Kunitz published an astronomy book. Elisabetha and Johannes Hevelius were a husband-wife astronomy team. Maria Winkelmann and Gottfried Kirch were a husband-wife astronomy team. The only way that Maria Winkelmann had access to the Berlin Academy of Sciences, though, was through her husband. When he passed away, she couldn't get back in until her son became an astronomer for the Berlin Academy of Sciences, even though everybody knew she was good at what she was doing. And Émilie de Châtelet helped Voltaire with his math and translated Newton's Principia into French. Over here we see a picture of Maria Kunitz's book, astronomy book, Urania Propitia. I assume it has something to do with Uranus. Writing for a female audience, Margaret Cavendish's description of a new world was called The Blazing World. It was published in 1666. There we see a picture of her. And Bernard de Fontenelle's Conversations on the Plurality of Worlds, which we see a frontispiece for that book there in French. And Alderoty's Newtonianism for Ladies, 1737. So everything you want to know about Newton's ideas for ladies. I don't know how, I didn't know language really changed that much between ladies and men, but there you go. Women were almost always barred from science and medicine until the late 19th century, the late 1800s. There was a belief from scholars in medicine and philosophy that women were inferior for medical reasons, philosophical reasons, a sort of prejudice against women existed going back to Greek philosophy and before that probably. And in medicine, there were arguments made that women were weaker than men and more prone to fits and things like that. The new science of religious faith. There are three issues involving religion and the scientific revolution. Biblical accuracy. The Bible did not always agree with this new science, and we still see issues with the argument over biblical accuracy today. Another issue was who would decide conflicts between the Bible and science. Would it be the clergy or would it be the scientists? And then whether or not to view this universe as a spiritual universe or a material universe. So most natural philosophers viewed their work as supporting faith, and because of this argument that they could reconcile faith with science, it created a lot of acceptance for what they were doing. The case of Galileo. The Church will condemn Galileo and Copernicanism. The Reformation had led the Council of Trent to make a reactionary claim of sole authority with the Bible. So this is going to become a really interesting issue with Galileo. They took a more literalist approach to hold off Protestant criticism. And then Galileo comes along and he claims that Scripture should be interpreted to agree with science. And this is usurping the role of the Church in deciding what the Bible says. and it reminded some of the clergy of Protestant arguments. And here we see a painting, dramatization, if you will, of the trial of Galileo. In 1615, there was formal discussion in Rome with Galileo. In 1616, with the issue Galileo is raised. In 1616, Copernicanism is condemned. It's allowed to be discussed in theory. And in 1623, Pope Urban VIII, an acquaintance of Galileo's, is elected. He permits Galileo to openly discuss this theory of Copernicanism. So what does Galileo do? 9 years later, he publishes a book, The Two Chief World Systems, Dialogue on the Two Chief World Systems, and it's very critical. It's an imagined dialogue between a guy who believes in a sun-centered universe and a guy who believes in an earth-centered universe, and Galileo makes the guy who believes the earth is the center of the universe look like an idiot. And so there's a trial, 1633, about whether Galileo had disobeyed the agreement in 1616 to discuss it as a theory, and he is required to renounce his view and is placed on house arrest. It's not until 1992 that the Catholic Church will admit error in this. Blaise Pascal, Reason and Faith. He's a French mathematician and scientist. He surrenders his wealth to live an austere life and tries to reconcile science with faith. He wants to refute dogmatism and skepticism, both. He wants to reject Jesuit dogmatism and its casuistry, which casuistry is the minimizing of sin with rationalizations. He thinks sin is a really big deal, and we'll get to that in the next slide. He also rejects skepticism as anathema or opposed to religion, and believes it will simply lead to atheism and deism. And he never really wrote a comprehensive argument, a complete argument against either dogmatism or skepticism. He just basically wrote about them occasionally in his books and complained about them. Here we see some of Pascal's math. This is his triangle for binomial coefficients. And you can see through the animation how this works. I'm not going to try to explain it. I'm a history teacher, not a math teacher. So Pascal's allied with the Jansenists. If you remember, the Jansenists were a group that would be persecuted in France under Louis XIV. He believed in total human depravity, which goes to original sin. He believed in predestination and the notion of faith or grace as the way you get saved. This is not really kind of the, a typical kind of emphasis for a Catholic sect. It's very similar to Protestants, certain Protestant groups like Calvinism. But he argued that religion was not the domain of science. He believed that a loving God exists, that humans are unworthy of God, and this is not going to be something the church is going to be exactly happy with, the Catholic Church. And he believed atheists and deists overestimated reason. He argued there were limits to reason. There are things you just couldn't figure out through reason. And he brings up his wager, Pascal's wager. He argues it is a better bet to believe God exists just in case. If God doesn't exist and you believe in him, you end up in the same place as the guy who doesn't believe in him. If you do believe in God and he actually does exist, then you're saved. And if you don't believe in God, you go to the bad place. That's kind of Pascal's argument. He doesn't really believe this is why someone should believe in God, but he's just making a kind of an intellectual argument about faith and reason more than anything else. He believed faith improves psychological and moral life. And now we get to the English approach to science and religion. Francis Bacon had argued that God created nature and the Bible, and that both must be compatible. So if you can study both to understand God's plan. In Newtonian times, people believed that we lived in a world that was mechanical, orderly, created by a rational being, a rational entity, a rational creator. And so from these ideas of Bacon's arguments and Newtonian worldviews, you get physico-theology, which is basically the argument that you can study nature to make religious conclusions. And this reconciliation of faith and science would allow new knowledge to spread rapidly, and the argument was made that if God was rational, man was rational as well. So then we get in the late 17th century, and natural philosophy will be associated with consumption in the market economy. John Ray will write The Wisdom of God manifested in his works of creation in 1690. And he argued that man's purpose is to understand the world, then put it to productive use. So now we have kind of a materialistic plank to religion. So God's plan is science and economic advance, because these things would lead to improving the world.